Welcome to the third video in our PsychoPy tutorial series. Today we're going to continue to use our pivot tables here to further summarize our data. I'm going to introduce you guys to if statements, and we're going to look back at some good organizational principles that we kind of skipped over in the first tutorial, and you'll see now why we should have included those things. And we're also at the end of this video going to make a figure. So we're going to go through all of those steps today. So in our last video, we had just finished creating our pivot table, and we could now see the average likelihood that someone would say yes to either blue, green, or new items. Now, one other thing that we can do with our pivot table before we go on to if statements is that we can include anything we want in this value section here. So let's drag out the probability of yes. There was one other variable that PsychoPy collected for us that we haven't really looked at yet, and that is reaction time. So it's this variable here, key test RT. Remember, in the experiment file, we labeled everything nice and clearly, so if we go back and look, key test was the key that somebody was pressing at the test phase. So once again, those naming conventions that we started with in the very first video are important. Don't get lazy and stop naming things, guys, because your data files will quickly get confusing when you're wondering what does key_5 represent. Okay, so this is the reaction time, the speed with which people made their responses, regardless of whether they are yes or no's. So let's go and put that into our pivot table and look at some average reaction time speeds. So here it is, key test RT. We'll drag it under values. Now at first it's giving us counts, so it's telling us there were 3 reaction times for blue, green, and 6 for new items for each subject. But again, we're going to go ahead and switch this to average. Now we can see the average speeds with which people were responding in our experiment. And so you can see that blue items, on average, took less than a second, green items took a little over a second, and new items were the fastest of all. Now these reaction times don't mean much because there's only 3 subjects and they were all me and I was just kind of messing around. But assuming we had many more subjects and this was a reliable difference, we might be able to interpret this as people responding differently to green items or blue items. Now, one more thing we can do with our pivot table here is imagine that we are only interested in cases where people said yes. So maybe we just want to see the reaction times, the speeds, for items where people said yes. So how can we get this information? Well, one way you can do it is by using that PS variable. So thinking about what we're doing with our data file here, there are some responses in which people said yes. There are others where people said no. We only want to look at the reaction times when people said yes. So how can we tell our pivot table to do that? Well, we're going to take this PS variable, and there's 2 ways to do it. First, let's use it as a filter. So by dragging PS into filters, now it is a filter variable, and if I click here, by default it's selecting all cases of PS. I can switch that to only select cases where PS is equal to 1. And if I click OK, now I'm getting average reaction times, but only for cases where people said yes. And if you remember our first subject, the first time I ran this experiment, I had no yeses to green items and no yeses to new items. So these cells are blank, indicating there are no reaction times defined here. Now, if we are subsequently interested in the reaction times when people said no, we can go ahead and switch that to 0. And now these are the reaction times where people said no. So you can use filters to sort out and leave out parts of your data if you're only interested in some component. Now what happens if we're interested in both the yes and the no responses, right? So maybe we want to compare, are people faster at responding to blue items when they say no as opposed to when they say yes? Well, you could make this table, copy the data out of here and paste it over here somewhere, and then you could switch your filter to look at the yes responses and do the same thing. And then you could have 2 tables that you've pasted out here and you could look at the numbers and compare, but that's not an efficient way to do it. A better way to do it is to take PS and just drag it over and make it another column variable. So let's put it before word color at the very top. And now what you'll see, this looks like a lot, but I'm just going to highlight everything and just center it so that our column headings are nice and clear. What's happening is first the pivot table is sorting things by probability of yes. and there are zeros and there are ones. There are also blanks, which just means that's the study phase, so we don't care about that. So there's times where PS was equal to 0, times where PS was equal to 1. And then below that, if you look at our column section, the next thing we told our pivot table to do is sort by word color. So after you've sorted by yes or no, then sort by blue, green, and none. And look, these are the numbers that we saw before when we were using our filter. And so right in a single table, we can see what's the average response speed for blue items that people said yes to, and the average response speed for blue items that people said no to. And you can see the no's are faster than the yeses. Interestingly, for greens, it's the other way around. Again, there's so few subjects here that we realistically wouldn't make much of this, but imagine a larger data set. If we saw patterns like this might be something worth interpreting. So you can include multiple variables in the column section. You could always include multiple variables in the rows section, but I don't advise it. It's good practice whenever you're creating a table. You should have participants be in the rows and nothing else. You should have a single variable be in the values and nothing else, and often you want this to be either an average or sometimes a count. And you might include a filter or two, but it's really filters and columns is where you could add multiple variables. So for instance, we could filter by all sorts of other stuff. We could include a number of variables in the filters, and we could drop out certain types of participants and so on and so forth. Okay, I'm going to revert this table to how it was when we first saw it. Switch it over to an average, and here we go. So this is the probability of saying yes to blue, green, or new items. Now, if we think to how we calculated the probability of saying yes, we type that in manually. And I said in the previous video that this is a bad way to do it because it's open to errors, and realistically, only with small data sets like this could you ever do this. With a larger data set, with a realistic data set, you need a computer to do this. It's a waste of your time to do it manually. So how do we get the computer to do this? So how do we get the computer to assign a 1 every time there's a yes and a 0 every time there's a no, and if it's not in the test phase, to just ignore everything else? Well, we're going to use a function in Excel called an if statement. The way an if statement works is if you go to an empty cell here. So here, this cell, we want it to have a value of 1. And we want that value to depend on the value of this cell. So here's how you enter an if statement in Excel. You begin by typing equals, and then you type the word if. And you'll see that Excel starts to autocomplete this. And it tells you this function checks whether a condition is met and returns one value if true and another value if false. Great. Use an open parentheses, and then you'll see Excel is giving you some hints of what it needs. It needs some logical test that it can perform. And if that test comes out true, then this cell is going to take on a certain value. And if that test comes out false, the cell will take on a different value. So the test that we want to perform is we want to check if this cell is equal to Y. So we can actually just click on this cell, and you'll see it's typed in O10. That is this cell, O10. So if O10 is equal to Y, and put Y in quotation marks because it's a letter, then we put a comma, and now that's the condition the if statement will check. If this turns out to be true, then what value should this cell take? Excel is asking us. Well, we want it to be 1. We can put a comma now, and now Excel is asking us if this test turns out to be false, what value should I take? And we're going to give it a 0. We can close this and type enter, and our first cell seems to work. I'm going to copy this, and I'm going to hold shift and press down to highlight all these other cells. And now I'm going to paste. And look, Excel has just done all the work for us. We can go and verify that some of these are right. So we can look at 2 cells. Okay, that's correct, that's correct, that's correct. And we can make sure that we've typed our equation incorrectly. But lo and behold, Excel has done all the work for us. So this is great. So your first inclination may be I'm going to copy this cell. I'm going to start here. I'm going to hold shift, and I'm going to click down here. So everything is highlighted, and now I'm just going to paste, and all my worries should go away. And they mostly do. So you see Excel is in the sections where it should. It is calculating things, and it is assigning ones to yeses and zeros to nos, and that's great. So we're halfway there. There is one problem though. As you can see, it looks as though Excel is also making calculations when we aren't even in the test phase yet. So actually, we want all these cells to be 0. So how do we make Excel pay attention to whether it is in the right section and only assign ones or zeros when it is? And the answer is actually another if statement. So here's how this works. Rather than first checking if the O column is equal to Y, before we even get to that point, let's check to see if this column has anything in it. Because if this column is blank, then it means we don't need to do anything really. We could also check these columns because these columns will also have values when we're in the test. It doesn't matter what column we check. We could check this column. All we're going to do now is before we even bother to calculate a 1 or a 0, we're going to check, do one of these columns that belong to the test phase have something in them? If so, we're in the test phase and carry on with the 1 or 0 calculation. If any of these cells, if whatever cell we pick is blank, then we know we're not in the test phase yet, and so we shouldn't do anything. So here's how this works. I'm going to erase this for a moment, and I'm going to insert a new if statement. And what I'm going to check is whether this cell right here is equal to nothing. And you indicate nothing by putting 2 quotes. So is this cell blank? If it is, then my own cell's value should also be blank. If it isn't, then I'm going to take on a value. And the value that I want is the previous if statement. So if this cell is equal to Y, then take on a value of 1, otherwise take on a value of 0. So look at this equation that we've typed in. First, check if O2 is equal to blank. If it is blank, then be blank. If it isn't blank, then check if O2 is equal to Y, and if it is, take on a value of 1, and if it isn't, take on a value of 2. So these if statements can embed within one another, and you can make very complicated decisions in Excel, and Excel can parse and calculate your data in a very sophisticated way. So we're going to copy this cell. I'm holding Shift right now, and I'm clicking on the last cell that I want to fill in. And now all I have to do is hit paste, and now all the areas where we shouldn't be calculating a 1 or a 0 are left blank. And the 1 and 0 calculation is only occurring in the test phase. So this may seem like a complicated way to go about adding in 1s and 0s, especially when you feel like you could do it by yourself, but get comfortable with this because this is actually a very simple statement to write. It takes only a few seconds. You copy it down and it will save you several minutes of work in real data files. And indeed, when we get to more complicated decisions, it's going to save you a lot of work. So let's calculate one more if statement before we get on to our figure here. Let's say that in addition to knowing the likelihood with which someone would say yes to a blue or a green item compared to new items, we also would like to know the likelihood that someone would just say yes to an old item in general, so a blue or green item, or a new item. So we want another way to categorize our stimuli where we can lump blue and green items together and just call them old items, and everything else we'll just call a new item. Now, it turns out that in our stimulus file, we didn't keep track of this information. We kept track of whether something was green or blue, and those are all old items. But what we really want is another column that just keeps track of generally whether the item is old or new, and it doesn't care about color. Now, we could have done this. So if we go back to our original word stimuli, if we want, we could insert another column here, and we could call this old new. And we could call all of the 6 studied items old and all of the new items new. And this may seem a little redundant, but think about if we want to analyze data in our pivot table later. If we want to group all these items together, they need to belong to the same category. Some being green, some being blue is not going to work because they'll be separated out in our pivot table. So if we had included this column ahead of time, and we should have included this column by the way, then when we run our experiment, our data file will come out with one more column. So let's just run this experiment real quick and see what the output will look like. We're going to call this participant number 4. So once again, welcome to our experiment. The words are going to go by. I'm going to recognize them, and then we'll look at the data file together. All right, so opening up this new data file, what we're going to find is that there is now an extra column called old new. You can see during the study phase, all the items were old. During the test phase, there was a mix of old and new items. So if we quickly make a pivot table for this new data set, what we'll be able to do that we couldn't do in the other data set is sort items by old new status. So old new goes under column, then PS, which I've copied, by the way. I did this really quick off camera. I copied PS from the other Excel file. But now we can get an average for both old and new items. So for all the blue and the green items together, in this case, I recognized every single one of them. The probability of a yes was 100%. And for 2 of the 6 new items, I was also accidentally saying yes. I'm making mistakes intentionally, by the way, guys. I don't actually have a terrible memory. So this is good for all new data files, but what about our old data files where we forgot to include the old new status? Well, we can actually fix that. We can create our own old new status, and we can have Excel do the calculations for us. So here's how we do it. Let's go down here to our first test item, and we're going to introduce a new if statement. What we want to check is whether this value here is equal to blue or green. So if we need to do one or the other, we can use another function within the if statement called or, which allows us to do multiple checks. So we're going to click on this cell. So if A10 is equal to blue, you can watch me type right up here, or A10 is equal to green, either of those is going to work, then we want to take on the value of old. Otherwise, we want to take on the value of new. So again, in this if statement, we're checking A10, and we're checking whether blue or green, and we indicate or by using this or function, are there. And if they are, then this cell is equal to old, otherwise it's equal to new. And if we copy this down, then we can see that Excel is going to start sorting which of our items are old and which of our items are new. Now, in order to make sure that this function doesn't just fill up other sections of the experiment, we're going to use the same trick we used over here, and we can really just copy and paste what we've got here. So this is the part of the if statement that checks if O2 is blank, and if it is, then our cell becomes blank. And we're just going to paste it right here. And we need one more parentheses at the end. So this looks like a very complicated if statement, but if you've been following along, hopefully you can decode this and see that it's actually not that complicated of a check that's occurring. Now, if we copy that down and we paste, then what we find is we are now correctly sorting out whether items are old or new. And again, we can go back and check a few random items to make sure it's working, but I'm pretty confident that it is. So, going into our pivot table, we say, all right, now let's include old new in the columns instead of word item. And we go down and we don't find old new. And we remember that when we created our pivot table, we only selected all the way out to column V. So we didn't select column W. So you have 2 options here. You can erase your pivot table and create a new one, or you can simply go into your pivot table options and change the data source. So somewhere in your options menu, you will have this option here of changing data source. If you click this, now you get to reselect the data that your pivot table is based on. So rather than going all the way out and stopping at V, we're now going to include column W and click OK. And now old new is showing up. We can drag it into the columns, and very quickly it is calculating the probability of old and new items for us. And there you have it. So 2 good lessons here. One is how if statements work, and they're very important. But another is that when you're creating your stimuli files, think about how you're ultimately going to want to sort them and deal with them. Include variables that are going to be useful to you later. You can include them post hoc using Excel scripts, but sometimes it's easier to just include, for instance, an old new column from the beginning, so that if you want, you can sort items by whether they're old or new. And maybe also there are different categories of items here. So you might have item type, and this could be like a person and an object and a place and an object, etc. So if later on you think, oh, I have different kinds of words here, I might want to look at the different categories and how people respond to them, include that information in the stimulus file. Otherwise, you're making your life a lot more difficult for you later on. Now, one other minor correction here before we go on. Look at this. We have a participant who's identified called participant who has a 0 here. We need to get rid of this or it's going to screw up our averages. So how do we actually remove that person? So that is a small error in our script. If we look here, what we see is that, hey, there shouldn't be an old new rating here or a probability of yes rating here, but we're getting one. How come? We have a bug in our script. Well, look at what the if statement is doing. It's checking to see if this cell isn't blank. Well, it's not blank, but it doesn't contain a yes or a no, so that's actually a problem. So we want these cells to actually be blank, so we need to tweak our if statement a little more so that it doesn't accept that this is a row in which it should compute a value. So let's write a slightly different if statement. So there's many different ways that you could correct this, but I want to show you guys a few other things you can do with if statements. So let's do this. Let's look at the AND function. I already showed you OR, let's look at AND. So how could we build an if statement that's an AND function that will take care of things? So let's say if this cell is not blank, so if we want to see if a cell is equal to something, we put equals. If we want to see if a cell is not equal to something, we put less than greater than. So if this cell is not blank and this cell is not equals to key test dot keys, then we want to check if this cell is equal to yes. So here's the final form of my if statement. It's a big if statement that first checks to see if this cell is not blank and not equal to test keys. Assuming that is all true, then we want to go ahead with our yes calculation, turning it into a 1 or a 0. And if that is not true, then it goes ahead and fills the cell with a blank instead. And if we copy this, select the first cell, hold Shift, click, and then paste, then we can look and see that, yep, now all the cells are being computed correctly. So now we just have to fix this one because we don't want an old new rating here. So let's do it this way. Let's just check to see if this cell is blank or not. This cell does all the calculations, and anytime there's a 0, we want an old new rating, or 1, but if it's blank, we don't want anything. So rather than going through a big complicated if statement for this one as well, let's just cheat and say if the V column is blank, you be blank too. Otherwise, you create an old new rating. And we can copy this cell, and we can paste it down here, and lo and behold, now all the old new ratings line up. If we hop back over to our pivot table, here was the problem. It still seems to be there, but here's one more tip with pivot tables. If you update the raw data, they won't update. You have to go and click on them to refresh. So as soon as we refresh this table, this row is going to go away because we fixed things, and lo and behold, it does. So now we have the proper, you see the mean here changed. It was 0.1, now it's 0.11111. So having errors in your raw data or in your if statements will lead to these little minor issues. So make sure that you're correcting things. All right, well that's it for today. In our next video, we're going to take all this and we're going to produce some figures. And so you'll see how to graphically visualize everything that we've done here today. All right, so we'll see you in the next video.